everyone, welcome to our channel Knowledge of Friends. Subscribe to our channel and click the bell icon for the latest update. आज हम लोग डेटा वेयर हाउसिंग एंड डेटा माइनिंग की क्लास करने वाले हैं, जो कि क्लास नंबर 10 है। ऑलरेडी हमने 9 क्लासेस कर लिया है। इस सब्जेक्ट की अगर हम बात करते हैं तो डेटा वेयर हाउसिंग डेटा माइनिंग में हम यूनिट 4 कर रहे हैं, जिसमें हमने यूनिट 1 कंप्लीट कर लिया है एंड यूनिट 2 कंप्लीट कर लिया है, यूनिट 3 कंप्लीट कर लिया है, and we are doing unit 4, which is your classification and clustering here. So in this whatever we had taught and learned in the last classes, that is all about unit 4, and hopefully if it is not exceeded more than 1 hour, we will be surely completing this unit in this class only. And the first of all, it's a huge request from my side to all the viewers, please go through with the subscribe button and please like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. So let's go ahead with the detail, and that what we have to discuss here is to explain the market basket analysis and to describe the concept of association rule mining, which has been asked of 10 marks. The other question that they can ask you in the reference towards this only, that what do you mean by the association rule, for what purpose it is being used, and explain with it examples, that is also of 5 marks. The other question they can ask you in terms of the related like this only, that is to describe the mining association rule in the large databases, that has been also asked of 5 marks. So let's go ahead to discuss each and everything in the reference towards it, what they had asked, and all the 3 questions, and that we'll discuss in detail as well. So first of all, we'll start with discussing about that market based analysis. Market based analysis. In the market based analysis, if I'm talking about here in the term of it, and that is in a market based analysis, that the customer buying habits are analyzed by finding association between the different item that customer places in their shopping basket as well. By finding such association, retailers develop marketing strategies here, and in the same case for the marketing strategies, and by analyzing which item are frequently purchased together by the customer, and this association that can lead to increase the sales by helping the retailer to do selective marketing and plan their shelf space as well. For example, if the customers are buying milk, how likely are they to be to also buy bread on the same trip to the supermarket? So by placing the bread and milk within a close proximity may encourage the sale of these items together within a single visit of the store as well, to the store as well. So initially, that market basket analysis is used to find how item purchased by customer are related. So like a bread and a milk, so that is the sub in the supermarket, that sub as your 5% confidence, your 100%. So that is a market based analysis. We'll talk about the another one in the detail, which is your association rule mining, which has also been asked in this only. Association rule mining. In association rule mining here, where association rules are an important class of method of finding the regularities pattern in data, and it is most important model invented and extensively studied by the databases and data mining community. And this rule mining finds interestingly associations or the correlations, relationships among a large set of data items with increased amount of data continuously that being correlated and stored. Industries are becoming interested in mining association rule from their databases. The association mining has been used in many application areas. One of the best known in the business field, where discovering of purchases pattern or association that between the products is very useful for the decision making and effective marketing, such as catalog design, cross marketing, and a loss leader analysis as well. Now we'll talk about the basic concepts. In the basic concepts here, let I will be I1, I2 till IM is a set of items, and that the transaction T is the transaction of item, and that T is a subset of I as well. And transaction T contains X and a set of item, that is the item set. And an association rule is an amplification of the form where we can say that X tends to Y, and where X and Y, that is a subset of Y, and X intersection of Y, which we have a common, that is your null as well. An item set, that is a set of an item for example, like X is your milk, bread, and cereals here is an item set. So a K item set is an item set with a K items. For example, like we have here is in the form of like milk, bread, cereals, that is the 3 item sets here. For rule strength measurement, that what we have to see it, and for that the rule here, rule strength measure. So in the rule strength measure, we'll talk about it, which is your the first we have is your support. In the term of the support here, that is that the rule holds with support, that is your sub st, and the transaction data set. If sub percent of the transaction contain X into union Y, then the sub is equals to of that PR of X union or Y as well. The other one is your confidence. In the term of the confidence, other than support, that is the rule holds in the T with confidence, and that and if the percent of the transaction that contained X also contain Y, then conf F, that has been an association rule, is a pattern that states when X occurs, Y occurs, and with that certain probability as well. In the same case, talking about the next one which we have is the support count. In the support count, that the support count of an item X, item set X, that denoted by the X count in the data set T, is the number of the transaction in the T that contains X, and that assume the T has n transaction as well. Then we can say that the support will go ahead here as well, which is support equals to X union Y count upon n. So you can go through and you can go and for that find it out the confidence here. So for that same case, the confidence we have X union Y count upon X dot count. So that is that rules that satisfy both minimum support threshold and the minimum confidence threshold, that are called the strong association rule. And the association rule of mining is of two-step process. The first is to find all frequent item set. That is the first step. Find all frequent item set. In this, that each of the item set will occur at least as frequently as predetermined minimum support count. The second step we have is to generate strong association rules from the frequent item set. So in the same cases here, that is that the rule must satisfy minimum support and minimum confidence, and the additional that is interesting that measure that can be applied as well. Where in the same cases, we'll talk about in that in a detail as well. So let's go ahead here. So where we'll talk about another one, which is to explain large item set. Now this is a new heading. In in the large item set here, so here that is an item set is any subset of the set of all items, and that is a large item set is an item set whose number of the occurrence is above here, and in the same references a threshold, and as well as we use L to indicate a complete set of large item set, and L to specific large item set as well. Where in the same cases association rule for the notation that we'll talk about it, that the capital D is represented that the database of the transaction, and TI is the transaction in the D, and the S small s is been representing the support, and A alpha like that is representing the confidence, and capital X and capital Y is representing the item sets, and X tends to Y, that tends to association rule. Then capital L is a start set of large item set, small l is the large item set in L, and capital C is the set of candidate items set, and of course the small p is the number of partitions as well. So where in the same references, when all the large item sets are found, generating the association rule is a straightforward, and algorithm that is given below, which is modified, outlines this technique. And in this algorithm we use a function support which returns the support for the input item set as well, and with reference to what. So as of the algorithm, that the capital D stands for the databases of transaction, and I is your item set, L is your large item set, S is your support, and alpha is your confidence as well. And the output we'll get is in the form of R, which is the association rules that satisfy S and alpha as well. So Arjun, that algorithm that we have here is that R equals to null, and for each small l that belongs to capital L, then do for each X is a subset of L such that X is that's not equals to null, do, and if the support of L upon support of X that is greater than or equals to alpha, then of course the capital R is equals to R, and that is of union that 1 minus X as well. Let's go ahead to discuss about another thing, which is to describe the Apiary algorithm for a FIM, that is a frequent item set mining, and verify it through a suitable example that has been asked for 5 marks. And the other question in terms of it, what is association rule mining, and explain the Apiary algorithm to find the frequent item set as well. So in the same case, that has been asked for 10 marks. So let's go ahead to discuss about it here, which is your Apiary algorithm. In the terms of Apiary algorithm here, which is Apiary algorithm as the most popular algorithm that is used for finding a frequent item set for Boolean association rule, and it uses a prior knowledge of frequent item set properties as well. It employs 2 steps. The first is that it find all item set that have minimum support, which is your frequent item set, and also called a large item set as well. The second is that it uses a frequent item set that to generate the rules as well. So here we'll go ahead with the step 1, which is your mining all frequent item set. In this step 1, which is your mining all of frequent item set, that what we have to discuss about it in the level wise, and which is your step 1. So in the terms of step 1, we have mining all frequent item set. A frequent item set is an item set whose support is greater than and equals to the minimum support, and which is your min-zap. And here in this, so with the same concept, that is the property, and that the level wise of search if I'm talking about. So find all the 1 item frequent item set, then all 2 item frequent item set, and as well as so on. In each iterations k, only consider the item set that contains some k minus 1 frequent item set as well. You consider the data set T, which is min-zap equals to 0.5, and that is your the TID and the item set as well. So T100, which we have 1, 3, 4, and T200, which is 2, 3, 4, and 2, 3, 5, and T300, 1, 2, 3, 5, and T400, which is 2, 5 here. This is the item set is the count. So in the scan T, we'll be finding out scan T that we are representing in the level wise as well. In the talking about the second step which we have here, which is step 2, that is you're generating rule from frequent that the item set. Generating rules from frequent item set. So in this, that the frequent item sets are not equal to association rule, and to generate the association rule for each frequent item set X for each proper non-empty subset from A of X as well. So let B equals to X minus A, where A tends to be is an association rule if that the confidence A tends to be is greater than equals to min conf, and that is for example, suppose that 2, 3, 4 is a frequent with sub equals to 50%, and that the proper non-empty subset we find it out in the form of 50% and then of course 75% respectively here. So these generates these association rule with the reference of what the confidence that they applied all, and all the rules have a support of 50% as well. Where in the same case for the algorithm, if I'm talking about here, so that will the large item set properly, and the a priori that the a priori algorithm itself is a rather straightforward, and in this algorithm we use Ci to be the count for the item, and that is of I that belongs to I as well. In the same cases for the initial candidate that are said to be the item as well, and that K is used as the scan number as well. The initial count for the each item sets are the, that is 0 as well, and that the a priori algorithm that assumes that the database is a memory resident, and the maximum number of the database that scans is one more than that the cardinality of the largest item set as well, and that this a potentially large number of the database that scans is a weakness of the a priori approach as well. Let's go ahead to discuss about why is the task of mining frequent item set difficult, and explain the reasons as well. So let's go ahead here. Task of mining frequent item set difficult. So in this, that the task of mining frequent item set that is difficult. Why it is a task of mining frequent item set is difficult? So in that you have to explain, that has been even though asking of 10 marks as well. So the task of mining frequent item set is difficult because it is difficult to find a strong association among the data items at a low or a primitive level of the abstraction due to the sparsity of the data in a multidimensional space, but strong association found at high concept level that might represent the common sense knowledge, but what may represent as common sense to one user that may seem new to another as well. In the same references, thus it is required that the data mining that should provide the capabilities to mine association rule at a multi-level of abstraction and traverse easily among different abstraction space as well. And following are the some reasons why the mining of the frequent item set is difficult. The first is that the computation required to generate the association rule grow exponentially with the number of item set and the complexity of the rules being considered as well. In the same case, where the item sets are assumed to be identical except for one identifying characteristics such as the product type, not all the problems that fit this description as well. The most difficult task is to determine the right item of the item set that to use in the analysis. By generalizing the item, one can ensure that the frequencies of the item set that is used in the analysis are about the same as well. It is difficult to generate the association rule when there are the item set that rarely occur in very few transactions as well. Now we'll go ahead to discuss about in a detail, which is to describe the mining single dimensional Boolean association rule from a transactional databases as well, and that has been asked of 5 marks as well. So let's go ahead to discuss here. Mining single dimensional Boolean association rules from transactional databases. In the same cases here, for let us take an example of association here, where A tends to C, that support A union C, that is of 50 degree 50%, that the a priori principle says that any subset of a frequent item set that must be frequent. But now to find out the frequent item set, that is set of the items that have a minimum support, and a subset of a frequent item set that might also be a frequent item set, that is if AB is a frequent item set, both A and B that should be a frequent item set. Iteratively find frequent item set with a cardinality from 1 to k, which is k item set, and then use the frequent item set that to generate the association rule as well. So here the first we have as a join step. In the join step, where ck is generated by joining lk minus 1 with itself. The second we have prune step. In the prune step here, where any k minus 1 item set that is not frequent cannot be subset of frequent k item set as well. So now we'll go ahead with this, and that what we'll discuss about it, and that is to describe the a priori algorithm and finding the frequent item sets, and that is using the candidate generation. This has been asked of 5 marks as well, which is also comes under in it, and that is your the a priori candidate generation. In the a priori candidate generation, that is in this algorithm, a superset that is called the candidate of the set of all frequent k items is obtained, and it has a 2 steps as well as I told you about it, which is the join step here itself to generate all possible candidate item sets C of k of length k, and the prune step that remove those candidate in ck that cannot be frequent as well. Here that for example, like we have here 1 2 3 1 2 1 1 3 4 1 3 5 and 2 3 4 in the function. So but after join, that will comes out as 1 2 3 4 and 1 3 4 5 as well, where in the same cases after pruning we can say that 1 2 3 4, because 1 4 5 is not in this function of subset that is removed, so that the candidate can generate it here. The step 1 is your joining, and the step 2 is your pruning. So for that we'll insert it in the form of an algorithm that we'll discuss here. Step 1, which is your self joining. In the self joining talking about, so that we have insert into ck, that is to select p item 1, p item 2, p item, where in the same cases for that we'll go ahead for a selection in that p of item here, and that is of p item k minus 1. So from lk minus 1 p, lk minus 1 q as well. So here with the same reference, we have p item here, p item 1 equals to q item 1, p item k minus 2, q item k minus 2 here. So here in the same references we can say that p dot item k minus 1 is less than 2 dot item k minus 1. So the step 2 we have pruning. In the terms of the pruning here, that for all item set C in a C of k, that do here for all item set C in ck, do for all k minus 1 subset S of C, then do here if S is not in Lk minus 1, then delete C from Ck here. And that is the another we'll discuss about it, which is the another question, and that is here is in the same references towards it, which is to discuss the methods to improve a priori efficiency. Methods to improve a priori's efficiency. Methods to improve the a priori efficiencies here, that the following are the various methods to improve the a priori efficiency, and the first we have is your hash based item set counting. Hash based item set counting here, where a k item set whose corresponding hashing bucket count is below the threshold that cannot be frequent. The second we have is your dynamic item set counting. In the dynamic item set counting here, that add new candidate item set only when all of their subset are estimated to be frequent. The third we have, which is transaction reduction. In the transaction reduction here, a transaction that does not contain any frequent k item set is useless in a subsequent scans as well. Talking about the fourth one, which is your partitioning. In the term of partitioning, any item set that is potentially frequent in DB that must be frequent in at least one of the partitions of database. The fifth we have is your sampling. In sampling, we are mining on the subset of a given data that lowers support threshold, and a method to determine a completeness as well. Let's go ahead to discuss many more things in reference towards this, which is the first we'll have to discuss about sampling algorithm. In the sampling algorithm, what we'll discuss is that the sampling algorithm is used to facilitate efficient counting of item set with large database, and it reduces the best case number of the database that scans to 1 in the average case and 2 in the worst case as well. Second, we'll discuss about the partitioning algorithm, where for that the generations of the large item set that may technique have been proposed, and that is based on partitioning of the set of transaction. and that what we had discussed about the partitioning algorithm, and for the generation of the large item set, that many techniques that have been proposed based on partitioning of set of transaction, and in this that D is divided into the p partitions where d1 d2 till dn, and the third one we'll discuss about it, which is your parallel and distributed algorithm, where in this the association rule algorithm that strive to parallelize either the data known as the data parallelism or the candidate that referred to as a task parallelism as well. The multi-level association rule will discuss about it, which is difficult to find the strong association among the data item at lower level of abstraction due to the sparsity of the data, and the strong association that is discovered at a high level of abstraction that may represent a more refined knowledge, and hence mining of the multi-level association rule that are used, in which association rules are that at a multiple level of the abstraction that are mined with the sufficient flexibility for easy traversal among the different abstraction level as well. There we'll discuss about the method as well, which is your uniform support, a reduced support, and a group based support as well. In the same case, we'll discuss about the multidimensional association rule, where we have to discuss about the association rule that involves the two or more dimensions or the predicators that can be referred to as multidimensional, and the type of multidimensional association rule are as to be follows. The first we have is your interdimensional association rule, where the association rule which has no repeated predicates, that each of which occur only once in a rule, and the second is the hybrid dimensional association rule, where that comes under the association rules with the repeated predicates and which contain the multiple occurrence of the sum predicate as well. Now we'll discuss about the another question which is in detail, and that is to explain mining multi-level association rules from the transactional database, which has been asked of 5 marks. So let's go ahead here. Mining multi-level association rules from transactional database. So in this, that the approaches to the mining multi-level association rule that are based on the support confidence framework, and normally top-down strategies is employed, where the counter accumulated for the calculations of frequent leverage item set at each concept level, and starting at a concept level 1 and working towards specific concept levels until more frequent item set that can be found using the Apiary algorithm here. The first we have is that using the uniform minimum support for all levels. Using uniform minimum support for all levels. In this, that when a uniform minimum support threshold is used, the search procedure is simplified, an optimization technique that can be adopted based on the knowledge that the ancestors in a superset of its descendants. The search avoids the examining item set that containing any item whose ancestors do not have minimum support. The main drawback of uniform support approach is that the item set at a lower level of abstraction will occur as frequently as those at higher level of abstraction as well. The second we have here is you're using reduced minimum support at lower levels. So in this, that each level of abstraction that has its own minimum support threshold, and that the lower the abstraction level, the smaller the corresponding threshold as well. The following such strategies for the mining multiple level of association with reduced support that are as to be follows here. In the same case, the first we have is your level by level independent. In level by level independent, it is a full breadth search and that no background knowledge of frequent item set is used for pruning, and here each node is examined regardless of parent and node is found to be frequent as well. The second we have is your level cross filtering. By single item. In this, an item as an ith the ith level is examined here, and is if and only if its parent node at the level of I minus 1th here level is frequent. That what it comes about it, and that what it discussed about it here. So now we'll discuss about the moreover in the terms of it another one, which is the third one as well, and even though the last one as well, that is your level cross filtering by kth item set. Level cross filtering by k item set. So in this, that an item set at ith level is examined if and only if its corresponding parent A item set at an I minus 1th level is frequent here. Now we'll go ahead with another one which we have to discuss about it, which is to explain the mining multidimensional association rule from a relational database and a data warehouses as well, which is of 10 marks here. So let's go ahead to discuss about it, which is mining a multinational association rule with relational that is the database and the data warehouses as well. So here in the levels cross filtering by the key item set, that is an item set at ith level that is examined if and only if it is corresponding parent A item set at the I minus ith level is frequent. Now we'll discuss about, as I told you about it, which is your mining multidimensional association rule from the relational database and the data warehouses. That what we have to discuss here in a detail here. So let's go ahead with this. Mining multidimensional association rules from relational database and data warehouse. So in this, that has been asked of 10 marks. So with this, that the association rule with the two or more dimensions or the predicate that can be referred to as a multidimensional association rule. Like for example, we have age, which is x 20 to 29, that the occupation is x like student, and buys an x, that is your laptop. So that this rule contains the three predicate, this rule that contain these predicate, that is your age, occupation and bias, and each of which that occurs only the ones in the rule, and such rules are called interdimensional association rule. And where the rules with a repeated predictive predicate or contain a multiple occurrence of the same predicate that are called hybrid dimensional association rule, and which is your that in the same case, for example, like age is from 20 to 29 and buy that laptop, and that buys an experience as well. So in the same cases, I'll talk about it, which is the database attribute that can be categorical or quantitative, and the categorical attribute that have a finite number of possible values with no ordering among the value, also called a nominal attribute as well. In the same case, for the quantitative attribute that are the numeric and have an implicit ordering among the values, and three basic approaches that regarding the treatment of the quantitative attribute that are as to be follows. The first, we have the first approach, that is your quantitative attribute that are discretized using the predefined concept hierarchy which occur to the prior to mining, and that the discretized numeric attribute with their ranges value, and that can be treated as a categorical attribute as well. In the second approach, the quantitative attributes that are categorized in a bind based on the distribution of the data, and these bins that may be the further combined during the mining process. And here the process of discretization is dynamic and established as well. In the third approach, where the quantitative attributes that are discretized so as to capture the semantic meaning of such interval data, and this dynamic discretization procedure that consider the distance between the data points as well. Where in the same cases, we'll discuss more in the detail about the classification by the backpropagation, which is the backpropagation is a neural network learning algorithm, and the neural network is simplified model of the biological neuron system, and that it is a parallel distributed processing system made up of highly interconnected neural computing elements that have ability to learn and thereby acquire knowledge as well. And each element that has a weight here as associated with it, and that the weight are modified in a backward direction as well, and that is from output layer through each hidden layer down to the first hidden layer as well. We'll talk about more detail about multi-layer of feed-forward neural network, where that is iteratively learning of a set of weights for the predictions of the class label of tuples. It consists of the input layer, one or more hidden layer, and an output layer as well. The genetic algorithm, if I'm talking about here in this, that the genetic algorithm in this, that the population of the rules that evolve by operation of crossover and mutations until all the rules that within the population that satisfied a specified threshold as well. So where we'll go ahead with the detail that what we have to discuss in a detail, and that is to describe the neural network and how the neural network is useful in classification. So let's go ahead. Neural network and how the neural network is useful in classification. So in the same cases, this has been asked of 10 marks. A neural network is a network of simulated neurons that can be used to recognize the instance of pattern, and the neural network that can learn by searching through a space of network weights, and as well as a neural network that is a set of connected input and output units where each connections has a weight associated with it, and during the learning phase the network learn by adjusting the weight so as to be able to predict the correct class label of the input samples, and where the NN learning is also referred to as a connection learning due to the connections between units as well, where some of the data has been hidden, the information has been processed from input, then hidden, then output, and the carriers that are known as their weights as well. In the same cases, the neural network that require a long training times, they have been criticized for their prior or poor interpretability, since it is difficult to interpret the symbolic meaning behind the learning weight, and these features initially made neural network less desirable for the data mining. The neural network include their high tolerance to the noisy data, as well as their ability to classify the patterns on which they have not been trained. Various algorithms have been developed for the extractions of rule from the trained neural networks. These factors contribute towards the usefulness of the neural network for classification in data mining as well. Let's go ahead to discuss about in the detail about any other topic, that is what you mean by a neural network that has been asked, and explain the multi-layer feed forward neural network, and of course the difference between the feed forward and a feed backward system. So in the neural network which we had discussed here, and that is of 10 marks as well. Now we'll talk about multi-layer feed forward neural network. In the multi-layer feed forward neural network we'll discuss here. Multi-layer feed forward neural network. In this, that the back propagation algorithm that performs learning on a multi-layer feed forward neural network, and that is that in the input corresponds to the attribute measured for each training samples, and that the input are fed simultaneously into a layer of units that making up into the input layer, and the weighted output of these units that are fed simultaneously to a second layer of neurons like unit known as hidden layer, and the hidden layer is a weighted output which can be input to another hidden layer, and so on. The number of the hidden layers that are in is arbitrary, and usually one is used, and the weighted output of the last hidden layer that are input to units and making up to the outer layer, and which emits the network predictions for the given samples as well. Where in the same cases that the units in the hidden layer that are the output layers and are sometimes referred to as the neurons, and due to their symbolic biological basis on the output unit, the multi-layer feed-forward network of the linear threshold function given enough here, that is a hidden unit that can be closely approximate any function here. So we are in the same cases, we'll talk about the feed-forward network. Feed-forward network. In the feed-forward network here, that is the feed-forward neural network that allows the signals to travel one way only, and from input to output. There is no feedback, that is your loops, that is the output of any layer that does not affect that same layer, and feed-forward network that tend to be a straightforward network and that associate the inputs with output, and they are extensively used in the patterns recognition, and this type of organization is also referred to as a bottom-up or a top-down here. And this is where the input has been given, the hidden layers has been represented there, and then after that we'll give the output as well. So this is your feed forward network which is in the forward direction. Next, talking about the feedback, that is your feedback network. In a feedback network, the feedback network that can have a signals traveling in a both direction by introducing the loop here, and that is in the network, and the feedback network that are very powerful and that can get extremely complicated, and feedback network that are dynamic, their states and are changing continuously until they reach an equilibrium point. They remain at an equilibrium point until the input changes and a new equilibrium needs to be found. The feedback architecture are also referred to as an interactive or recurrent, and although the later term is often used to denote the feedback connection in a single layer organization as well. That is your feedback network. Now we'll talk about the backpropagation algorithm, and what write a short note on a backpropagation algorithm which has been asked here. Backpropagation algorithm. In the backpropagation algorithm, if I'm talking about here, the backpropagation refer to the entire procedure that encompassing both the calculation of the gradient, and it uses in that is your stochastic gradient descent. Technically, the backpropagation is used to calculate the gradient of the error of the network with respect to the network's modifiable weight, and this gradient is used in the simple stochastic gradient that descent algorithm to find the way that minimizes the error. As the name implies, that the error propagates backward from the output nodes to the inner nodes, and the training algorithm of the backpropagation that involves the 4 stages. The first stage we have is the initialization of weight. In the initialization of weight, we have some small random values that are assigned here. The second we have here in this, that is your feed forward. In a feed forward, where each input unit X receives an input signal and transmits this signal to each of the hidden unit, which is your Z1, Z2 till Zn, and each hidden unit then calculate the activation function and send its signal Z1 to each output unit, and that the output unit calculate the activation function to form the response of the given input pattern. Talking about the third one, which is your back propagation of error. Back propagation of error here, each output unit that compares the activation y of k with the respect to the target value of t of k, that to determine the associated error for that unit, and that is based on the error that the factor which we have s of k, which is k can be equals to 1 till m, and that is computed and is used to distribute the layer. And similarly, the factor s of j, that is j is also equals to from 1 to p, that is compared from the each hidden unit, which is of j, z of j here. And the fourth we have is your updations of weight and biases. Updation of the weight and biases. So now we'll discuss about it, the last topic of the session of this unit, which is your fourth unit. This is another question, the last question which can be asked is describe genetic algorithm. In the genetic algorithm, and what do you mean by genetic algorithm? Explain with suitable. So in this algorithm, an initial population is created which consists of randomly generated rules and a string of bits that is used to represent each rule. And for example, that consider the samples in a given training set that would describe two Boolean attribute, which is A1 and A2, and that are of two classes, which is C1 and C2. The rule is if not A1 and not A2, then C1, and that can be encoded in the bit string which is 001, and where the two leftmost bits represent the attribute A1 and A2, that is respectively, and the rightmost bit represent the class as well. Where in the same cases that offsprings that are created by applying the genetic operators such as your crossover and mutations, and in crossover substring from the pairs of rules that are swapped to form new pairs of rules, and in mutations the randomly selected bits in a rule string that are inverted, and the process of generating the new population that is based on the prior populations of rules that continues until a population p that evolves the where each rule in p that satisfies a pre-specified fitness threshold as well. So here we'll end up with this, and in the next coming class we'll start discussing about it in the next class, and which is your that we had discussed here. So we had end up with this fourth unit, and then now in the next coming class we'll start with the unit of fifth, which is your data visualization and overall perspective, and which is the last unit as well. And after that we'll start discussing about the short answers questions as well. And here in this class you will be getting all the videos which we are uploading in terms of the computer graphics, principle of programming language, managerial economics, reasoning, and as well as quantitative aptitude. In unit 1, where we discuss about data warehouse, and that is your overview, definition, data warehousing, components, building a data warehouse database, mapping the data warehouse in the multiprocessor architecture, difference between the database system and a data warehouse, multidimensional data models and the data cubes, stars, snowflake, pack constellation, concept hierarchy, process architecture, three-tier architecture, data mining, marting as well. The unit 2 is your data warehouse process and technology, which is your warehousing strategies, warehouse management and support, process, warehouse planning and implementation, hardware and operating system for the data warehousing, client server computing model and a data warehouse, parallel processor, cluster system, distributed DBMS implementation, warehousing software, warehouse schema, design, data extraction, cleanup and transformation tool, warehouse metadata as well. In unit 3rd, which we have to discuss about data mining and deduction, which is overview, motivation, definition and functionalities, data processing, form of the data processing, data cleaning, missing values, noisy data, pinning, clustering regressions, computer and human inspection, inconsistent data, data integration, transformation, data reduction, data cube aggregation, dimensionality reduction, data compression, numerosity reduction, discretization, and concept hierarchy generation, decision tree as well. In unit 4, which we had covered up in this class, which is your classification and clustering, which is we had discussed about classification, that is your definitions, data generalization, analytical characterization, analysis of attribute relevance, mining and class comparison, statistical measures in the large database, statistical based algorithm, distance based algorithm, decision tree based algorithm. In clustering, we had discussed about the introduction, similarity and the distance measured, hierarchical and a partition algorithm, and hierarchical clustering, Cure and Canadian, density based method, which is DB scan, optics, grid based method, which is a sting click, model based method, statistical approach, association rules, as well as the introduction, large item set, basic algorithm, parallel and distributed algorithm, neural network approaches, which we had done in unit 4. And now we'll start discussing about unit 5, which is we have to discuss about data visualization, where we have to discuss about the aggregation, historical information, query facility, OLAP function and tools, OLAP solver, rollup, molap, holap, data mining, interface, security backup and recovery, tuning, data warehousing, testing data warehouse applications and recent trends, types of warehouse application, web mining, spatial mining and temporal mining as well. And then we have to discuss about very short answer type question, which is also an important one. So first of all, it's a huge request from my side to all the viewers, please go through with the subscribe button and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. You will be finding each and every video as I told you. Thank you, hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion in the comment box. Thank you.